Hello, I'm Emma-Louise Coffey and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. With so much focus on the environment and emissions, did you know you can cut your emissions by up to 20% while maintaining output and profit? Researcher James Humphreys explains how this is achieved in practice at Teagasc Solohead. But first, James gives some background information to the research farm.
We've around 130 acres. It's in South Tipperary. It's near the racecourse, Tipperary Racecourse or Limerick Junction. We've milked 140 cows this year, 139 at the moment. The farm, it's a heavy enough farm. We've two problems in terms of soil water. One is we have a shallow water table. So on the farm is quite low lying. It's next to a river which runs on two sides of the farm, and then there's another permanent stream running through the farm. So at any one time the water table is quite close to the surface. In the winter time on the lower lying parts of the farm it's at the surface. At other times of the year it might fall down to a metre, maybe 2 meters, and the higher part of the farm then it falls to 2 or 3 meters. So the water table is never far away. And the second thing then is we've heavy subsoil. So we've got about 20 centimeters or 8 inches of good topsoil. Below that then it starts getting increasingly clay, and when you get down to maybe 40 centimeters or so, you're into white marl, this very heavy white marl, and water moves through that very slowly. So for every centimetre of rain or every 10 mils of rain, the water table will rise up by about 16 centimetres. So over the last 10 days or so now, we're after getting over 100 mils of rain. So the water table is right at the surface as we speak, which in the month of August is a difficult, it's a difficulty, and that's something we've had to deal with. We have to manage the cows obviously in terms of on-off grazing and that sort of thing, but over the last number of years, every year we've done a small amount of drainage, maybe spent 4,000 or 5,000 on drainage, just solving different problems on the farm. And to a large extent now, we don't really have as much of a problem as we said we had 15 or 20 years ago. Like the farm is very productive, and even with the rain that we've got in recent year, over the last 10 days or so, it's not a problem as we speak.
And I guess, look, that is very relevant to right now, not so relevant to the conversation today. But if we can, I suppose, what is your advice, James, for farmers who are dealing with the same circumstances as you? You know, we're seeing across the country, depending on, you know, the soil type and the ability of soils to manage water, there are a lot of farmers who are maybe gone in by night, and, you know, if rainfall continues, you know, they may have to go in by day and continue on off grazing across the full day for the foreseeable until things dry up.
Yeah, it's very hard to say because there's a lot of differences between different farms. We've been using a soil moisture probe, and at the moment the soil moisture is up around 55. We're kind of approaching the point where you'd say, well, we'd need to take the cows off. Now, if it gets above 60, 65, that's when we would start on-off grazing. So at the moment, it's fine. But of course, there are differences in different parts of the country. On-off grazing works fine, 4 hours in the morning, 4 hours in the evening. We found that you can maintain your output, same level of milk output. You can put the cows in. What we did was put the cows in, they're out for 4 hours, go back in, out again after the evening, milking 4 hours, put them in for the night. And we didn't feed them anything when they were inside. They're just inside on the cubicles, and they're fine. They adapt to that situation very well, and they're just as productive as if they were out full time.
And looking, James, to I suppose the conversation that we plan to have today, and it's around the idea of low carbon farming, and this is something that you're trialling and demonstrating at Solohead Farm. Can you document, I suppose, to start off, the gases that contribute to emissions from Irish dairy farms and look at the intensity of emissions from dairy farms relative to the other enterprises in the country?
When people think about greenhouse gases, what they primarily think about is carbon dioxide. Say from fossil fuel, you can imagine power stations burning fossil fuel and releasing carbon dioxide into the atmosphere. And I suppose that's the thing that most immediately springs to mind. But when we look at a farm, say when we look at national emissions, carbon dioxide is the big one. When we look at a farm, if we look at a dairy farm, methane is the single biggest emission. So if we take Solohead, for example, around 50% of the emissions coming off the farm are methane generated by the cows and the replacements. And the way that we can lower that is to maximize our lifetime milk output per cow and to lower our replacement rate. And that's through using the EBI. The next big emission is nitrous oxide, which it's a very potent greenhouse gas. It has 300 times the global warming potential of carbon dioxide. Now, nitrous oxide, where that comes from, primarily from the application of fertiliser. So when you go to apply fertiliser, it falls on the ground, gets absorbed into the ground, taken up by the grass. That's what you hope happens. But during that process, a small amount of nitrous oxide escapes during the process of the fertilizer being broken down and converted into the plant available form. A small amount of nitrous oxide escapes. But that has a huge impact on the emissions from a farm. So around 20% of the emissions from Solohead, where we're using high fertilizer nitrogen, is in the form of nitrous oxide. The other thing that happens during this process is we also get losses of ammonia. Now, ammonia isn't a greenhouse gas, but there are also limits there are also reduction targets for ammonia. So if we can switch away from using nitrogen fertilizer to alternatives, we immediately help to solve the problem of nitrous oxide and also ammonia. The other source of nitrous oxide is the slurry from the cattle, from the cows and the replacements. And also their dung and urine out in the field. So around another 20% of the emissions would be from the slurry, dung and urine. So that's about 90% of our emissions. And then the other 10% is carbon dioxide. And that comes from the various processes, say electricity generation for running the milking parlour, diesel fuel for tractors and that sort of thing.
And James, with all of that in mind, you're looking at various strategies to quantify how much you can reduce your emissions by on farm. So you have, a standard base system, and then you're looking at different scenarios, differentiating from that. Can you give us some information across the strategies and the practices?
I suppose going back to your previous question to some extent, like when we take the three main gases, you have methane, nitrous oxide, and carbon dioxide. It's very difficult to lower methane, and with existing technology now, there is research going on to look at different additives to lower methane emissions from cows. But as things stand, there's nothing immediately available, and when something becomes available at some point, there'll then be questions about how suitable. What are the risks associated with that? Maybe it's being introduced, some new contaminant being introduced into the food chain. So there will be questions around that. And as I said, methane is around 50%. Another 20% comes from the excreta. So the work we're doing at Solohead is focused more on the nitrogen side of things, the nitrogen fertilizer and managing the slurry. So if we take our standard system, type of system, Moore Park blueprint type of scenario that we've been running for many years, 2.5 cows per hectare, using 280 kilos of nitrogen per hectare. Standard Canon urea. If we switch over to using only protected urea, combined with low emission slurry spreading, optimal management of slurry, using a trailing shoe, we can cut our emissions over the entire farm by around 9%. And that's something that can be done relatively easy. It's a relatively easy thing to switch over. Switching from can urea to protected urea isn't a big difficulty, and using a trailing shoe instead of splash plate is pretty straightforward. The next system that we're looking at then is where we, instead of using the full rate of protected urea, we use a half rate combined with clover. And that's where we're going on with around 100 kilos per hectare of clover in the spring. And then we'll use maybe another 25 kilos at this time of the year just to extend the grazing season. And using that kind of a system, we can cut emissions by around 18%. And then the last thing we're looking at, which is very much experimental, and we've been rolling it out in over the last 2 years, is looking at where we cut nitrogen fertiliser out of the equation altogether and just rely purely on clover. And when we take that type of approach, we're looking at around a 25-26% reduction in emissions across the whole farm. That's really where we're only relying on clover and recycled slurry.
And you mentioned there that the output from your standard system is 1.2 kilos of carbon per litre of milk produced, James. What is the target level that you would aim to get to?
There is a question about how we measure, or what we include and what we don't include in these measurements. And the approach we're taking is what you call a global approach, where we look at all the emissions, whether they originate in Ireland or whether they originate abroad. And what I'm primarily aiming at there is imported concentrate from South America. We could also look at the figures from the point of view of national emissions, and there's pros and cons in both approaches. But the figures I'm quoting now are global figures. The reason for that is that if we compare systems across Europe or across the world, there's very little to differentiate an Irish milk production from Dutch milk production when we only look at national emissions. Where a big differentiation occurs is when we include, say, concentrate imported from South America. So when we do an international comparison, our milk then comes out with a much lower carbon footprint. And if you look at it from a consumer's point of view, what they're primarily interested in is the global impact of the food that they're buying. So when a German consumer or a UK consumer are buying, say Irish butter, for example, and if we can show it as a lower carbon footprint, it's the global impact that they're concerned about, and that's really why we're focused on those type of figures. So on that basis, we're looking at going from around 1.2 down to what we're achieving at the moment is 0.7. Our target is to get down to around 0.6, which would be a 50% reduction.
And I guess from the practices you have highlighted, switching from the standard urea and can that farmers have used, kind of widespread on farms to protected urea, looking at low emission slurry spreading like the trailing shoe, reducing the overall amount of artificial fertiliser used, and also introducing clover. These will all have a massive impact, and cumulatively what you can estimate is that it's going to reduce emissions by 25%. I suppose looking to practicalities on farm, James, across these scenarios. So when you move from that standard base or blueprint that you talked about at the start, if you move to the situation where you're reducing the amount of nitrogen spread, or you're cutting out nitrogen altogether, is there an impact on production?
If we take the first step, say going from can urea to protected urea and using low emission slurry spreading, there's no real impact there. There's no impact. If you take the second step there, switching half the protected urea to clover based system, there's a lot of data now in Moore Park. We have a lot of data in Solid. Say there's no difference in production between those two systems. when you move towards the no nitrogen situation, like the levels of production that we're getting at the moment would be around 95% of where we're using 250 kilos of nitrogen per hectare. And that might be surprising, and it is somewhat surprising. But when you think about clover-based systems, say if we're using clover with 125 kilos of nitrogen per hectare, as soon as we start taking that nitrogen out of the system, we start to fix more nitrogen. So the less fertilizer you apply, the more nitrogen the clover will fix. So there's a compensatory element there. Now we've done some some of our older work. It is a while ago now. We looked at the economic comparison of clover-based systems with the fertilizer-based systems. And even if we lose some production, say 90% of the output, the clover-based system can still be as profitable because you have lower costs. So there's a compensatory element there in terms of the economics. So we'd be confident enough to say that, say, particularly going the first step, say half rate of nitrogen with clover, it's unlikely to have an economic impact in terms of output. The next step then, that's more of a question, but that's work in progress. As I said, we're only into the second year of that. So, it's something we're going to have to.
It'll be really interesting, James, to see 2 and 3 years down the line, do those trends continue, where, as you say, you've no impact for your first 2 changes, but for the third stage where you're cutting out nitrogen altogether, at the moment you're at 90 to 95% of the performance, and there's a substantial cost associated with artificial fertiliser on farms. So as we say, very, very interesting. A few more practicalities to discuss, James. In a way, like the things like protected urea and the trailing shoe, they're no-brainers. A conversation we've had last week with Mark O'Sullivan, all irrigation farmers are now using the trailing shoe or, other low-emission slurry spreading methods. But, taking it a step further and introducing clover across the whole farm, that's not going to be done overnight. And I suppose from your perspective at Solohead, you would have pioneered a lot of the clover research, in the last 15 years or so, that has impacted on what farmers are doing across the country today. How long is that process?
I think there's a major there's a major obstacle there, and as we speak, a lot of the Teagasc farms now are going over to clover-based systems, and that conversion process is a massive challenge, because really when you're in a if you're in a high production system, it's different to what we were doing, say maybe 15 years ago when in the REP scheme, but at the current time when dairy farms are generally fairly heavily stocked, to make a conversion, you're really looking at reseeding. You really need to be looking at reseeding to introduce clover into the swards. And there is a limit to how much of a farm that you can reseed in any one year. What we kind of recommend to people is to build up a stock of silage before conversion. Some parts of the farm could already have some clover that could be promoted and enhanced by oversowing, but fundamentally you're talking about reseeding. And then as you're going through the process, you have the problem of bloat. Now, we've never really had a problem with bloat at Solohead because we've maintained cows on. When we have a clover system, we keep the cows on the clover from spring right throughout the year. What you can't really do is move cows back and forth between swards that are very high in clover and with no clover, because that's really very high risk of bloat, particularly during July and August, September. And that creates a problem for conversion. So there are obstacles there, practical obstacles that need to be considered and need to be, if somebody is considering converting, is to have a clear plan in place. In terms of the motivation for it, I think it's clear enough. Economically, it can be positive, certainly in terms of ammonia and nitrous oxide emissions. But as things stand, the policy or our government policy around this is not at all clear in terms of what's expected of farmers. So I don't know what to say about that in terms of recommending it to people as things stand.
And as you say, it's been put in across a lot of Teagasc farms at the moment. There is a lot of research, but for farmers, individuals who are doing it, a strong plan needs to be put in place as how you are going to implement it on your farm. And I think that's a good tip you have as well in terms of ensuring that there is sufficient silage in the yard before you take this on. I suppose, on a silage note, James, we talk an awful lot about white clover for dairy systems. Is there a role for red clover within conventional dairy production systems?
Well, what we've been trialing now in the last couple of years is putting red clover into the grazing mix. So we're putting in maybe 2 kilos of red clover, 2 kilos of white clover, and 10 kilos of ryegrass. And we're into the third year of that now, and we're very happy with it in terms of giving us a good boost to production. Now, the expectation with red clover is that it doesn't last very well. If you got 4 or 5 years out of it, you'd be considered to be doing very well. If you got 2 or 3 years is kind of what's typically expected. But like red clover is hugely productive. It is a much higher capacity to fix nitrogen than white clover. Like white clover, you could be talking about up to 200 kilos of nitrogen per hectare. With red clover, you're talking about up to 300 kilos. So putting red clover in a reseeding mix for grazing silage, primarily for grazing, we find that that has worked very well and certainly made a positive contribution. The other area we're looking at is on outside blocks, where you're cutting maybe 3 or 4 cuts of silage and maybe some zero grazing. And again, it's holding up very well there. In that case, we're using 4 kilos of red clover with a hybrid ryegrass, 8 kilos of hybrid ryegrass. And I think in that situation, okay, you're going to be looking at reseeding a lot more often, maybe every 4 or 5 years. But productivity-wise, we're talking we can easily hit 16 tons in the first full year of production and maintain that for 2 or 3 years, maybe two. You're talking about maybe 4 or 5 year production cycle before you need to reseed again.
To finish up, James, can you identify 2 or 3 benefits that ye see from implementing low carbon farming at Solohead?
Practically, I think it's fine in terms of milk output. We can achieve high levels of milk output. I think profitability, the indication so far is that there's not a major loss in profitability, or at least we can maintain similar level of profitability, which is key. And then the third thing is, of course, we big reduction in, well, look, we'll say maybe 20% reduction on dairy farms in greenhouse gas emissions. Whether that'll be enough to satisfy the regulators or not, is a question. And the other big question, of course, is future expansion. Like, is there capacity within that scenario for future expansion? And if you go back again to the motivation for this work, like Professor John Sweeney was on the television there a couple of nights ago, and he was talking about cutting the national herd by around 20% to meet our greenhouse gas emissions. I think if we start cutting numbers, then we cut our national capacity for output. So I think maintaining the national herd is our number one priority, and that then focuses in on looking at where else we can make reductions. And I think putting clover in instead of nitrogen fertiliser has its difficulties, but it is something that offers us an opportunity, I think, to maintain our national output while still meeting these environmental requirements.
That's great. Thank you, James.
Thank you, Emma-Louise.
That's it for this week's episode of the Dairy Edge podcast, and my thanks to James Humphreys for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify, and for more information go to the Teagasc website at teagasc.ie. I'm Emma-Louise Coffey, and join me next time for your Dairy Edge.